In this lesson, we will define the average speed and the average velocity of a moving object. You will be able to calculate the average speed and the average velocity of an object in one-dimensional motion, as well as you should be able at the end of the lesson to interpret correctly the sign of average velocity. In other words, you should be able to tell what it means when the velocity of an object is positive or when the velocity of an object is negative. Keep in mind that average speed and average velocities are terms used to quantify how fast or how slow a moving object is. In other words, the fastness and the slowness of moving things are quantified using average speed and average velocity. An object's average speed is essentially defined as the total distance traveled by that object divided by the total time taken. Now, the quantity that defines both the speed of an object and its direction of travel is what we call average velocity. Average velocity is simply the total displacement of a moving object divided by the total time taken. In front of us, we have a jogging man, we have a clock, and a coordinate axis. His initial position is xi. So the question really is, what if he jogs to a different position? How do we quantify the rate at which he is jogging? How do we quantify the rate at which he is moving? So suppose he jogs to a final position. So this right here is his x final. That is his final position. Now the total distance traveled, d, is the distance covered between his final position and his initial position. His total displacement is simply delta x bar, because it's a vector. It's just the final position vector minus the initial position vector, which is just the final position minus the initial position multiplied by I hat, where I hat is a unit vector along the x direction. So what do we do now? His average speed v, I'm going to indicate the average speed by s. This is just defined as the total distance traveled divided by the total time taken So this means that the average speed is d divided by delta t. This is the definition of the average speed. Distance is measured in meters. The time interval is measured in seconds. This therefore implies that the SI unit for average speed is just meters per second. In other words, the dimensions of average speed is meters per second. On the other hand, average velocity V average bar is just the total displacement divided by the total time taken. This would mean that V average is just the change in the position divided by the change in time. It is worthwhile for you to remember that the displacement of an object is measured in meters, the time interval is measured in seconds. This would mean that the unit for average velocity is meters per second. So when you look at the definition of average speed and average acceleration, what you will find in common is that both are measured in meters per second. But speed is a scalar quantity, while average velocity is a vector quantity. Keep that in mind, while average velocity is a vector quantity. As a matter of fact, the average velocity of an object is the speed of that object plus its direction. The speed of the object plus its direction. So this brings us to one important point. If average velocity is a vector quantity, it means that it has direction. So how do we determine the direction of the average velocity of an object? We, by definition, V average is equal to the displacement of that object divided by the time interval. But now keep in mind that the time interval is always positive and it is a scalar quantity. When you divide anything by a scalar or a number, it remains that thing. That means that the direction, this is important, it means that the direction of average velocity is the same as the direction of displacement delta x. The direction of average velocity is the same as the direction of displacement delta x. So it means that if delta x is greater than 0, then the average speed will be greater than 0. Similarly, if delta x is less than 0, it means that the average speed is also less than 0. But the question I want to ask is, what does it mean for the displacement to be positive, and what does it mean for the displacement of an object to be negative? A positive displacement, if delta x is positive, it simply means that the final position vector is greater than the initial position vector. This is only true if the object is moving in the direction of increasing x. In other words, the object moves to the right. This implies that a positive velocity implies that the object is moving to the right. So the logical conclusion is that if v is greater than 0, imply the motion is to the right. On the other hand, if delta x is less than 0, this will mean that xf is less than xi. In other words, the only time in which the final position is less than the initial position is when the object is moving in the direction of decreasing x. If the object is moving in the direction of decreasing x, the final position will obviously be less than the initial position. When this is the case, the object is said to be moving to the left. Hence, we say that here object moves to the left. So, we can definitely conclude that if v is less than 0, the motion is to the left. The motion is definitely to the left. Now, this is really critical. I will summarize all of this in a diagram that will help you to remember. So keep in mind that a positive displacement, let's say that if an object initially is found in the positive axis, this means that x is greater than 0. If an object is located in the second quadrant, it means that x is less than 0. Now, let's say if the object is located in the first quadrant and moving in this direction, v will be greater than 0. If the object is located in the second quadrant and moving in this direction, v will be greater than 0. If the object is located in, this is the first, second, third, and the fourth quadrant. If the object is located in the third quadrant, x is less than 0. Now, here's the deal. If the object is moving in this direction, v will be less than 0. If the object is located in the fourth quadrant, x will be greater than 0. And if the object is moving in this direction, v will be less than 0. What do you notice? You notice that in the first quadrant, where the object is moving to the right, v is positive and x is also positive. In the second quadrant, in which the object is moving to the right, v is positive but x is negative. So my conclusion is here the object is moving away from the origin. Here the object is moving away from the origin. Here the object is moving towards the origin, and here the object is moving towards the origin. When you look at away, when the object is moving away, what do you notice? You notice that both v and x are of the same sign. When v and x, when the position and velocity are of the same sign, the object moves away from the origin. But when the position and velocity are of opposite sign, the object moves towards the origin. Let me say that again. When x and v are of the same sign, the object moves away from the origin. But when v and x are of the opposite sign, the object moves towards the origin. Towards the origin. So before we end this very short section, keep in mind that the sign of velocity signifies the direction of motion. A positive velocity means that the object is moving in the direction of increasing x, and a negative velocity implies that the object is moving in the direction of decreasing x. In other words, a positive velocity implies that the object is moving to the right, and a negative velocity implies that the object is moving to the left. Now, if the position and velocity are of the same sign, the object will move away from the origin. But if the position and velocity are of opposite sign, the object will be moving towards the origin, either from the right or from the left, as defined by this summary diagram. This is a very important diagram. Now, in front of us, we have two runners. We have Tom and we have John. Now, John weighs more than Tommy. So let's see what happens in this race. Obviously, it takes John longer to complete the same distance compared to Tom. So if we represent the motion of John and Tom on a position versus time graph, how is it going to look like? This right here is the time axis measured in seconds, and this right here is the position axis measured in meters. Now I had taken the liberty to kind of write down the positions and the time covered by Tom and John prior to this video. So let's plot how the position of Tom varies with time. At t equal to 0, x is equal to 0. So Tommy is initially at the origin. At this is 0. This will be 2, 4, 6, 8, 10, 12. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9. At t equal to 1, this is 2. At t equal to 2, let's add 4. At t equal to 3.2, we are at 6. At t equal to 4, we are at 8. Now at t equal to 5.2, we are at 10. So when x is 4, t is 3.5. When x is 6, t is 5.4. When x is 8, t is 7.6. Now when x is 10, t is 9. So let's do the graphs for both of them. So what do you notice? Obviously, you see that this is Tom and this is John. So let's calculate the slope of the graph for Tom and the slope of the graph for John. The slope of the graph is essentially defined as the change in the y-axis divided by the change in the x-axis, which essentially is equal to the average velocity. In other words, this is an important result. This means that average velocity is equal to the slope of x versus t graph, as long as the graph is a straight line. As long as the graph is a straight line. So obviously, from the graph, you can see that the slope for the graph that describes how Tom's position changes is way greater than that for Tom. So we can conclude that V of Tom is greater than V of John, simply by looking at the graphs.